The universe is roughly 13.8 billion years old. That's what we've been told for decades. It's the foundation of modern cosmology, the bedrock upon which every theory about galaxies, stars, and cosmic evolution has been built. But here's the problem. The James Webb Space Telescope has been operational for less than 3 years, and in that short time, it has systematically dismantled nearly everything we thought we knew about the cosmos. Lock your screens. Put on your headphones, because after this video, you'll never look at the night sky the same way again. When NASA launched Webb in December 2021, they promised revolutionary discoveries. What they didn't expect was existential crisis. Within months of its first deep-field images, astronomers around the world began sending each other frantic emails. Something was wrong. Not with the telescope, with the universe itself. Dr. Alison Kirkpatrick, an astrophysicist at the University of Kansas, publicly admitted what many colleagues were whispering privately. She said she had been awake at 3 in the morning, staring at data that made no sense. Galaxies that shouldn't exist. Structures that defied every model. Let me explain why this matters. For you to understand how significant these discoveries are, you need to grasp what Webb was designed to see. Unlike the Hubble Space Telescope, which observes primarily invisible and ultraviolet light, Webb operates in the infrared spectrum. This allows it to peer deeper into the universe than any instrument ever built, detecting light that has traveled for billions of years before reaching its mirrors. The deeper you look into space, the further back in time you're seeing. Light from a galaxy 10 billion light-years away took 10 billion years to reach us. You're not seeing that galaxy as it exists today, you're seeing it as it existed 10 billion years ago. This is the principle that makes Webb so revolutionary. It can see the universe's childhood. And here's what Webb found in that childhood. Fully formed adult galaxies. Mature, massive, structured galaxies, existing at a time when the universe was supposedly too young to have produced them. The galaxy designated Galaxies 13 was one of the first shocks. Detected just days after Webb began operations, it appeared to exist when the universe was only 300 million years old. That's roughly 2 of its current age. To put this in perspective, imagine finding a fully grown oak tree in a forest that was planted yesterday. The math doesn't work. Stars need time to form. Galaxies need time to coalesce. The heavy elements required for planets and life need multiple generations of stellar death and rebirth to be formed. Yet, there it was, Galaxy 13, bright, massive, and impossible. But Galaxy 13 was just the beginning. In July 2023, Webb identified a galaxy now designated JS-Z140, existing at a redshift of 1432 For those unfamiliar with astronomical terminology, redshift measures how much a celestial object's light has stretched as the universe expanded during its journey to us. The higher the redshift, the more ancient the light. A redshift of 1432 places this galaxy at approximately 290 million years after the Big Bang. 290 million years. The universe hadn't even figured out how to make proper stars yet, according to our models. There should have been nothing but hydrogen clouds and darkness at that epoch. Instead, Webb found a galaxy already containing stars, already producing light, already existing as a coherent gravitational structure. Dr. Brant Robertson of UC Santa Cruz, one of the lead researchers on the JADES team, described the finding as completely unexpected. The team had to rerun their analysis multiple times. They checked for instrument errors, calibration issues, data contamination. Everything came back clean. The galaxy was real. The timeline was real. The timeline was real. The contradiction was real. Here's where this gets truly unsettling. These ancient galaxies aren't small. They aren't the primitive dwarf galaxies that cosmological models predicted would exist in the early universe. Many of them are massive, some appearing to contain billions of stars already organized into spiral arms and disk structures that supposedly take billions of years to form. The Hubble Space Telescope gave us glimpses of this problem, but its resolution was limited. Scientists could dismiss anomalies as observational artifacts, Webb removed that excuse. Its infrared capabilities and unprecedented sensitivity delivered images so clear that the anomalies could no longer be rationalized away. In 2024, Webb observed a collection of galaxies, now informally called the universe breakers. 6 massive galaxies appearing to exist between 500–700 million years after the Big Bang, each containing stellar masses comparable to our own Milky Way. Dr. Ivo Labbé of Swinburne University in Australia, who led the analysis, told the scientific press that these objects should not exist. He wasn't speaking metaphorically. He meant it literally. Current cosmological models have no mechanism to produce galaxies of this size, this quickly. The European Space Agency, which partnered with NASA on Webb's construction, quietly updated their timeline projections. The Hubble tension, an ongoing discrepancy between different methods of measuring the universe's expansion rate, grew more pronounced. Something fundamental was wrong with our understanding of cosmic evolution. And if the timeline problem wasn't disturbing enough, Webb began revealing structural anomalies that compound the mystery. The cosmic horseshoe, officially designated SES-J 1148-1930, had been observed before. It's a gravitationally lensed galaxy whose light has been bent and magnified by a foreground galaxy cluster. Webb's new images revealed something unprecedented. The lensed galaxy appeared to contain globular clusters, dense spherical collections of ancient stars that typically require several billion years to form. But this galaxy existed when the universe was only 3 billion years old. Dr. Timothy Carlton of Arizona State University examined Webb's deep field images and discovered what he initially assumed was an artifact, a stream of stars stretching between galaxies, suggesting they had interacted and merged. The problem was the distance. If these galaxies were as far away as their redshift suggested, they existed at a time when galactic mergers of this complexity shouldn't have been possible. Here's the thing: merger events require time. Galaxies don't collide instantaneously. They spiral toward each other over hundreds of millions of years, exchanging gravitational influences, distorting each other's structures, eventually combining into larger systems. The stellar streams Webb detected implied multiple merger generations had already occurred in a universe barely old enough to have formed its first stars. What you're seeing isn't just scientific controversy. This is paradigm collapse in real time. The lambda CDM model, which has served as the standard framework for cosmology since the 1990s, depends on specific assumptions about dark matter, dark energy, and the rate of structure formation. Webb's discoveries don't merely challenge this model. They suggest it may be fundamentally incomplete. Some physicists have proposed radical alternatives. Dr. Eric Lerner, a plasma physicist who has long critiqued Big Bang cosmology, pointed to Webb's findings as evidence that the universe may be far older than 13.8 billion years, perhaps infinitely old. His position remains controversial, but the data is forcing mainstream cosmologists to at least engage with previously dismissed possibilities. Others suggest our understanding of dark matter is flawed. If dark matter behaves differently than models assume, it could allow for faster gravitational collapse, enabling galaxies to form more quickly than currently predicted. But this raises its own questions. If our dark matter models are wrong, what else might be wrong? The most disturbing possibility, one that several astronomers have raised privately but few will discuss publicly, is that we may be fundamentally misunderstanding what we're observing. What if the light from these ancient galaxies isn't telling us what we think it's telling us? Dr. Michael Boylan Colchin of the University of Texas at Austin published a paper in 2023 titled "Stress Testing Lambda CDM with High Redshift Galaxy Candidates." His conclusion was carefully worded but unmistakable. The abundance of massive galaxy candidates at cosmic dawn is in stark tension with predictions from our best theoretical models. Stark tension. In academic language, that's practically screaming. But wait, it gets stranger. Webb hasn't just found anomalous galaxies. It's detected chemical signatures that shouldn't exist in the early universe. The spectrograph aboard Webb can analyze the light from distant objects and determine their chemical composition. In 2024, Researchers examining an ancient galaxy detected significant quantities of elements heavier than helium, what astronomers call metals regardless of their actual metallic properties. These elements, carbon, oxygen, nitrogen, silicon, are forged in the cores of stars and dispersed when those stars explode as supernovae. The presence of these metals in a galaxy existing less than 400 million years after the Big Bang implies multiple generations of stellar evolution had already occurred. Stars had to form, burn through their fuel, explode, seed the surrounding gas with heavy elements, and that enriched gas had to collapse and form new stars, all within a time frame that conventional models consider impossible. Some researchers attempted to explain this through population the third stars, theoretical first-generation stars that may have been far more massive than modern stars and thus burned faster and died younger. But even generous population, the third scenario struggled to account for the metallicity levels Webb detected. The telescope also observed what appeared to be supermassive black holes in galaxies that shouldn't have had time to produce them. These cosmic engines, containing millions or billions of solar masses, typically form through the gradual accumulation of matter and the merger of smaller black holes. Finding them fully formed in the early universe is like finding a completed skyscraper on a construction site that broke ground last week. Dr. Priyamvada Natarajan of Yale University, an expert on black hole formation, described the findings as challenging everything we thought we understood about how the first cosmic structures assembled. Let's step back for a moment and consider what all this means. The James Webb Space Telescope cost approximately $10 billion and took over 2 decades to develop. 2 decades. It was designed to answer questions about the early universe, to observe the first galaxies, to help us understand our cosmic origins. Instead, it has generated more questions than answers, each observation deepening the mystery rather than resolving it. Scientists are not panicking publicly because that's not how science works. They're writing papers, proposing new models, scheduling telescope time for follow-up observations. The process will take years, possibly decades. But behind the measured academic language, a quiet revolution is underway. Fundamental assumptions that have guided cosmology for a generation are being questioned at the highest levels. Some have suggested that Webb's discoveries point to observational errors or calibration problems, but the telescope has undergone extensive verification. Multiple independent teams using different analysis methods have confirmed the same anomalies. The European Space Agency's calibration data matches NASA's. The galaxies are real. The chemical signatures are real. The problem is with our models, not our instruments. Here's what haunts astronomers most. Webb is still just beginning its mission. Its primary mandate extends through at least 2031, with enough fuel reserves to potentially operate into the 2040s. Every month brings new observations, new targets, new opportunities to either resolve these contradictions or deepen them. What if the next decade of Webb observations confirms and amplifies these findings? What if the universe truly is fundamentally different from what we've believed? Consider the implications. Our age estimates could be wrong. Our models of cosmic expansion could be wrong. Our understanding of dark matter and dark energy, which together supposedly comprise 95% of the universe's total content, could be wrong. We might be living in a cosmos whose true nature we haven't even begun to comprehend. Some philosophers of science have noted the irony. We built the most sophisticated eye ever pointed at the heavens, expecting to see our theories confirmed, and instead received evidence that we may have been looking at the universe through a distorted lens all along. The scale of the universe revealed by Webb isn't just bigger than we imagine. It may operate by rules we haven't discovered yet. Galaxies that formed too fast, black holes that grew too quickly, chemical elements that appeared too early. Each impossibility stacks upon the previous one, building a picture of a cosmos that refuses to conform to human expectations. And yet, isn't that exactly what we should expect? Humans have been observing the sky for thousands of years. We've been doing rigorous astronomy for perhaps 4 centuries. We've had space telescopes for less than 50 years. The notion that we had already figured out the fundamental nature of reality was always, in retrospect, somewhat arrogant. What Webb reveals isn't necessarily that the universe is stranger than we imagined. It's that the universe is stranger than we can imagine. Our models are approximations, useful tools for prediction, not complete descriptions of reality. The real cosmos has no obligation to fit our mathematical frameworks. The James Webb Space Telescope hasn't broken cosmology. It's shown us where cosmology was already broken, where our confident theories were masking profound ignorance. That's not a failure. That's science working exactly as it should. But here's what keeps me thinking long after the research papers close. If we were this wrong about the age and evolution of galaxies, what else might we be wrong about? If the early universe was already teeming with massive structures when we thought it was dark and empty, what does that mean for our understanding of cosmic destiny? If matter can organize itself this quickly, what other organizational principles might be operating that we haven't detected yet? The universe is approximately 93 billion light-years in diameter, containing roughly 2 trillion galaxies, each containing hundreds of billions of stars. We've directly examined a statistically insignificant fraction of this volume. Webb's deep-field images capture regions of sky so small they could be covered by a grain of sand held at arm's length. And even in those tiny patches, we've found mysteries that challenge everything we thought we knew. Some nights, when the sky is clear, astronomers look up and feel not just wonder, but genuine humility. We are small creatures on a small planet, orbiting an unremarkable star in an average galaxy, in a universe whose scale and nature exceed our capacity for comprehension. Webb is showing us that the gap between what we know and what there is to know may be far larger than we ever suspected. What will the next decade of observations reveal? Will we find explanations that restore our confidence in current models? Or will the contradictions multiply until we're forced to abandon fundamental assumptions and start again? The honest answer is that nobody knows, and maybe that's exactly how it should be. 6 stories of cosmic impossibility. 6 challenges to everything textbooks taught us about the universe, from ancient galaxies that matured too fast to supermassive black holes that grew too quickly, from chemical elements that appeared too early to structures that formed too completely. Webb has exposed the limits of human understanding with ruthless clarity. If you made it this far, thank you. Leave a like if any of these discoveries changed how you think about the cosmos. Tell us which finding disturbed you most and what you think Webb might reveal next. And remember, every time you look at the night sky, you're seeing light from objects whose nature we may never fully understand. The universe doesn't owe us comprehensible answers. It only owes us the light.